Hi everyone, and welcome to a quick video on graphing linear algebra. So the idea is that we're going to be representing 2n plus 1 on this graph right here, and the way for us to do it, and the way that I'm hoping that you will learn how to do it, is that we have to determine a table of values for this. This, as we know, says we've got two groups of n, and we're going to be adding 1 to it each time. So if we were to take and try to solve this using a table of values, t and v, t for the term number, and v for the value, and the value is going to be our answer that we're missing right here. So let's say that we want to know what the negative second term is, we want to know what the first term is, and we want to know what the third term is. Here's how we go about solving these questions. Anytime that we look at a table of values chart, t on this side is automatically going to become our variable. So this is going to be n. It's also going to double as an x coordinate, and the value is going to double as a y coordinate. So we'll talk about that momentarily when we discuss ordered pairs. So let's deal with our values first. So if we were to take -2 and we were to plug it into this equation that we have here, this algebraic expression, we're going to end up with 2 times -2, or two groups of -2. Well, we know that anytime we take a positive and multiply it by a negative, we're going to end up with a negative answer. So if we take 2 and we multiply it by -2, we get -4. But it's not just 2 times -2. We have this plus 1 that we didn't add yet, so we're going to add that right now. 2 times -2 is -4, and we're adding 1 to it. We end up with -3. Now let's do that for the rest of these real quickly here, just to get our values down, and then I'll show you how they get plotted on the graph itself. Let's do that with 1. So 2 times 1 is 2, plus 1 is +3. And then let's do it right here with number 3. 2 times 3, because our term number is going to be our n. 2 times 3 is 6, plus 1 is 7. So now I've got some values written down here, and I'm going to clean this up a little bit so it's a little bit easier to read. So just give me 1 sec while I erase some of these lines that I've created here. So -2, that was -3, this is +3, and this is 7. Okay, now we figured out what n's were. We figured out what the n was when we looked at these term numbers here. Now we're going to try and figure out how we plot them onto a Cartesian plane. I mentioned before that the table of values also will double as an x coordinate and a y coordinate. If you were to look at these numbers as ordered pairs, like we do when we are plotting coordinates, you'll see that you read it as -2, -3. And same thing if we go here, 1, +3, and then same here on this side, 3, 7. So when we look at an ordered pair as a whole, these are the coordinates that we're going to be using for this first term, or this second term. -2, so we'll slide over, we do x first, because that's the way we read it. Here's x and here's y. We read it left to right. We go over -2, 1, 2, and down to -3, and we end up with a dot right about there. Sorry about that. We end up with a dot right about there. -2, -3. Okay, now I know it's not exactly on the line the way that I would like it to have, but it would be about that vicinity right there. Let me see if I can try that again here. My finger's a little bit big for the iPad. Keep selecting make this a little bit larger. 1 sec. Let's try this. This might work a little bit better. Putting lots of small dots on there, but no big dots. Okay, so -2, -3, it's about as close as I'm going to get, but it would be -2, -3 right there on that line. Now the next one says 1, 3, so we go over +1 and we go up to 3, and we end up on about that section right there where you can see all those little dots forming. I'm just going to try and make it as close as I can to 1, 3. And then the final one says 3, 7. So we go over on the x-axis to 3 and we go up to 7, and we end up on a dot roughly about there. dot. Now, this is linear algebra, and what that means is that every time we're adjusting the term, we're adjusting it by a constant, which is the same. So you'll notice that if I was to take a line and connect the dots as best as I could, we're going to end up with a line that travels through all that space. Now that line will continue on, and that's kind of important because in linear algebra, what we can do is, now without doing any of the math on the table of values, now we can actually just size up the chart, and if we know how to read the graph, we know how to solve for what the value is going to be for various terms. So for instance, if I was to look at term number 4, -4 right here, I would go over 4, and then I would see that the line travels down to right there, which is -7. So I know that the -4th term is going to have a value of -7. Same thing if I go over onto the positive side. On the positive side, if I want to know what, like, let's say the second term, well, I go over to 2, and I go up until it matches the line, and now I know my second term is going to have a value of 5. And just simply by reading the graph, this line will continue on forever and ever and ever. As I go further down the line, I'm going to increase the value of what it is based on the term. I hope this video gave you a little bit more insight and a little bit more instruction if you needed it. By all means, if you have any questions, class, please email me.